Welcome to VINDAL'S Academy, and today I want us to talk about longitude and latitude. So even if you're a beginner, there are tips I'm going to be giving in this lesson that will further help you to master the principle of longitude and latitude. Now, but in order to do that, I'm going to be using the question I have on the hand, while the question will be pasted on the screen for you to see. Okay, so let's get started with this question. The question says, an aircraft flies from point P. So we have point P, which is 12 degree north, 11 degree west. Then this is point P. It flies from this point P to point Q. Point Q is 12 degree north to 11 degree east. So then it says in 2 hours, it takes 2 hours to do this journey, to take this journey, and then changes course, and it then changes course and arrive at point S, and that point S is 44 degrees north and 11 degree east, and this is point S. After, okay, it said in 6 hours. Now, after leaving point Q, they say calculate to correct to 3 significant figure the total distance covered and the average speed of the aircraft. All right, so I am going to, even if you do not understand anything about longitude and latitude, just pay attention to this. So let me draw it and sketch it. Let's assume that this is the Earth, the atlas, the world itself. So I have this part, which is my north, and this is south, which is called the Greenwich meridian. That means the line that divides the Earth into 2 equal parts through the middle. We call it the Greenwich meridian. I also have another line here. This is east and this is west. This line is also another angle from which the Earth can be measured. I can call this one the equator. All right. I am not holding the atlas, but let's assume that this is angle 0. All right. Now, looking at these 4 cardinal points I've drawn on the atlas, what you should understand is that from this point, which I similarly see as the center, from this point to the east is 180 degrees to the east. 180 degree to the east. So even if I draw one longitude, another longitude, maybe I can be spacing them 30 degrees from this to this place. I am not going to do that, but that is what it is. Also, another one from this same point to the west, which is also another 180 degree. But then going up this way, we call it latitude. So the latitude is also going to start from 0, increase until it reaches here, which is 90. You can also start from here, 0, increase and reaches here, which is also 90 degrees towards the south and towards the north. While to the east is 180 and to the west is also 180. Now, how do I sketch an aircraft flying from point P to point Q? So point P, I'm going to have 12 degree north. So this 12 degree is towards the north. How do I draw it? Like I said before, it is from 0 and keep on increasing. Any line I draw, which is a line of latitude, represents a given angle. So I'm going to draw the first one. Since it's 12 degree, is very close to this place, I'm going to assume that 12 degree is somewhere here. This is my 12 degree towards the north. All right. Then there is another one which is 11 degree towards the west. So 11 degree towards the west. If this is 0, for example, 11 degree will not be too far, but I'm just going to draw it so that it will be a bigger diagram for everyone to see. So I'm drawing it this way. This is my longitude. This is longitude 11 degree west, while this is latitude 12 degree north. Let me label it for everyone to see. This is 12 degree north and this is 11 degree west. All right, so The next thing I'm going to draw is this point Q. So the question should now be, what is the point P? The point P there is this place. I'm going to use the blue marker to show you this is point P. This is the coordinate. At this point is the coordinate between the north, 12 degree north, and 11 degree west. Now let me draw another point, which is point 11 degree to the east. So this is my 11 degree to the east. And if you check very well, you see this point is what? Q. That is the point of intersection. Now, how then do I complete it? Remember, all these lines I'm drawing, they are all circles. Some are great circle and some are small circle. Any circle of latitude can only be a great circle. Great circle is simply a kind of circle that has a radius of 6,400 kilometers radius. Is a great circle. If the circle is small, then it's a small circle. That means the radius will also be a small radius, which is not going to be up to 6,400 kilometers. Common sense, you know. So this circle, let me complete this circle. This is a small circle. And this small circle is not a great circle. So its diameter is going to be different. So I'm going to draw its diameter. I'm going to draw this line to represent the diameter of that small circle. It's just like you having a small circle, you know. So from here is 11, and from here to this place is another 11. So the angular difference between this and this is 22 degrees, right? Now that is not enough. It then left from P, it flew to Q, and left Q. From Q, it goes to S. How do I now plot this 44 degree north? Now, look, remember, I have taken the first one, which is 12 degree. 44 should be somewhere here. 44 should be close to 90, you know. So I'm going to draw it here. This is another small circle, even a smaller circle. So how then do I measure the angle? I'm going to measure the angle going up. So this is the point of intersection, which we now, let me just remove this line to avoid too many lines. All right. I'm removing this line for you to, good. So this is the first 12 degree north, and this is 44 degrees. So from here to this place, this is that point S. Okay. So the angle from here to this place is 44. While the angle from here to here is 12. So the angle separating them is going to be, 44 minus 12 is going to be 32 degrees. So I'm having two things, two smaller circles. Look at what I have. The first one is this. This is the first small circle, which is giving us 22 degrees. The radius is a small circle. Since it's a small circle, the radius is going to be capital R cos phi. This is the radius, because it's a distance along the latitude. Every distance along the latitude will have a different value compared to the distance along the longitude. Pay attention. So this is Q. So this particular one, this is a particular sector formed. There is another sector formed here, and that is the sector of the distance along the longitude, and that is given as this. And the angle between them is 32 degrees. This is from Q to S. So what happened here is this. The airplane flew from P to Q, then from Q to S. And we're going to find them. All right. Now, this one, since it is a distance along the latitude, the formula is going to be given as, I'm going to say PQ is going to be 22 over 360 times 2 pi r cos phi. Somebody will say, what is cos phi? Cos phi is this 12-degree north. Why this west and east added together is giving me the theta. Okay, sorry, I'm supposed to put theta here. Theta over 360. All right. So now remember, I have found the theta, which is 22, which is a normal length of an arc you find. So this 22, this place is 22 degrees. Why this phi? Remember, the phi is this 12-degree north, which is 12-degree north. Everything, I'm going to add everything. I'm going to add 22 times 2 times pi is 3.142 times capital R is 6400. So I'm going to say 22 times, let me pause the video and just multiply. Okay, so when I say 22 times 2 times 3.142 times 6400 times cos 12 degree, divide everything by 360 degrees, I will have 2404.035 approximately. That remember, the answer should be in three significant figure, but I'm not yet going to do that because I will do that at the end. If I do it here, it will affect my final answer. All right, let's do the next one. The next question is, remember why I'm using this formula. This formula can only be used for distance along the latitude of a small circle. But if it is distance along the longitude, longitude must be 0 degree north or 0 degree south. At that point, I will still use the normal formula. What is the normal formula? I am talking about the distance along the longitude. The distance along the longitude has this formula. It has this formula, which is given as theta over 360 times 2 pi capital R. Remember, so I'm talking about QS. So the theta is the difference of the angular difference. So this is going to be 32 all over 360 times 2 times pi is 3.14 times R is 6400. I hope this is showing in this video. So that is what we have right now. So the next thing is to say this is equal to 32 times 2 times 3. Let me just punch it in my calculator. 32 times 2 times 3.142 times 6400 divide by 360. So I have 3574.898 kilometer. All right, so this is the value for Q to S. But remember, I am looking for the total distance. Total distance is going to be from here to here and from here to here. I'm going to add PQ and QS. So let's do that. So I'm going to clean this. The analysis here is done. So the total distance is given as I'm going to have 2404.035 plus 3574.898. So that is the total distance. That is the total distance. But then remember, they say that my answer must be in three significant figures. I'm looking for 1, 2, 3. So which is 598.00 kilometer. No, 80.00 0 kilometer. All right. So this is the final answer for the total distance covered. All right. So, but the next question said average distance, average speed. What we mean by average speed? Average speed means total distance all over total time. Therefore, average speed, average distance is going to be, remember the total time is 2 plus 6, which is 8. So I'm going to have this divided by 8. So divide by 8. I'll have 7, 4, 747.367 kilometer per hour. So that is it. That is the answer. But then to trace significant figure, I'm going to have, I'm supposed to use this value divided by 8 to get this. But fine, I'll have to trace significant figure, I'm going to have 747.0 kilometer per hour. All right, so that is the second question. The last question says the time difference between Q and S. The time difference between Q and S. Remember, Q and S, there is time along this longitude. All the countries living on this longitude, on this line, they will have the same time. That is why this is the Greenwich Meridian. They say that London and Accra, Ghana, they fall on this Greenwich Meridian, so they have the same time. So the time difference of this and this is going to be 0. If the time here is 1 p.m., this time here is 1 p.m. 1 p.m. minus 1 p.m. is 0. So the final answer there is 0. So this is not really, it's not hard, but the space I have was making it a little difficult for me because I wanted it in this portrait form. Have a very great day. Don't forget to hit the subscribe button, like this video, and share it. Thank you.